Hi, and welcome to Lesson 5 in Unit 0, Algebraic Tools for the Grade 11 University Functions. We are looking today at factoring Part 3, grouping and substitution. Now, if you recall, we already looked at factoring by common factoring, by difference of squares, simple trinomial, and tricky trinomials. So today we're going to look at grouping and substitution. This is a type of factoring you may not have seen before in grade 10. So we're going to have a look at what happens when you have 4 or more terms. We've already looked at 2 terms and 3 terms and how to factor those. But if you've got an expression with 4 or more, then you still want to try common factoring first if you can common factor something out of every term in the expression. But if you can't common factor out of every term in the expression, then you might be able to break the expression into parts. So the whole notion of grouping is that you can possibly separate an expression like this. We have 4 terms here. We could take the first 2 and set them off to the side because I can see that there's a common factor of 5 and y there. And then the second pair we can take off to the side, and I can see that I can factor out a -3. And so by factoring by grouping, we separate and we common factor what we can out of the pairs that we've set aside for each other. So if we look at the first pair and we take out our 5y, we common factor that out, then we're left with y plus 2 as the third factor. So we've got a 5 times a y plus 2. When we want to factor the second pair, common factor the second pair, I recommend that you factor out whatever sign is in front of the second pair. So if it's a negative, common factor the negative out. If it's a positive, common factor the positive out. And so by common factoring the -3 out, I'm left with y plus 2. Now you know that your grouping is working, your factoring by grouping is working, if when you separate them out into parts and factor the parts, that those new terms are themselves factorable again. So you notice that in this first term we have 3 factors, 5 times y plus 2. And in the second term we have 2 factors, -3 times y plus 2. And we notice that the y plus 2, even though it's a binomial factor, it is still a factor that's in common to both terms. So we can common factor the y plus 2 out, and then what we're left with is 5y minus 3. If it helps, picture it as though this y plus 2 was just a single variable like z, and that you'd have 5yz minus 3z. You'd common factor the z out, and you'd be left with 5y minus 3. So picture that these binomials here are another variable if it helps you, and that's a strategy called using a dummy variable, which we'll use down below as well. If we look at the second example, again, we have 4 terms, and we're starting to get thinking about how can we factor this. I can't do some of the other types of factoring that I know because there are 4 or more terms. If I were to think to pair up the first 2, I can see that x squared is a common factor, and if I were to pair up the second 2, I could see that +3 is a common factor. So if I try that out, I take out the x squared, I common factor that out, and I'm left with x minus 4, and then I factor out the +3, and I'm left with x minus 4. I can see, again, that we've created something where we've got 2 terms. Each term has 2 factors. Technically, the x squared is 2, so this is really 3 factors, x times x minus 4, and this is +3 times x minus 4. Again, we can now common factor this expression by taking this x minus 4, this binomial factor that is in common, factoring it out, and then what we're left with is x squared plus 3, sorry. So now we look and see, is there any way I can factor any of these factors further, because that's our job, is try and keep going as far as we can. And we can't go any further here, so we know our work is done with this example. If we look at example 3, again, I'm going to pair them up. I'm going to go 2 and 2 because I can see I can take the 3a out of here and I'll be left with x minus y. And if I take a -6b out of both of these, then I'll be left with another x minus y. So by common factoring those out, then again I can see I've got a 3 and an a and an x minus y, and a -6 and a b and an x minus y. First thing I see to do is to take out the x minus y. But you can see in a second we're going to have to factor a little more, because in fact this term and this term also have a common factor of 3 that could be removed, which we'll do next. So if you don't do it right away, you can do it after. So notice if I common factor out the x minus y, then I'm left with 3a minus 6b. And I notice here, each of these binomials, this one can be factored further, so I will common factor the 3 out, so I'll just be left with a minus 2b. And by convention, we'll put that constant term out front, or if it's a monomial, we'll put that out front and then let the binomials follow that. Looking at the binomials, I can see I can't common factor or do any other kind of factoring further. So this expression will be the factored form of this one here. Example 4, 3x to the 5th minus 12x cubed minus x squared plus 4. Again, I'm going to try going with 2 and 2 because often that works, doesn't always work. If we can see that we've got a common factor of 3 and x cubed here, we can factor that out, and then I'm left with x squared minus 4. Again, I'm going to factor out this sign that's in front of this binomial here, take out this minus 1, and then what I'm left with is x squared minus 4. I recommend that you put the 1 in just so that you don't avoid it on the next step, and you'll see what I mean. Since the x squared minus 4 is a binomial factor that's in common to both of these terms, I'm going to factor that out, and then what we're left with is 3x cubed minus 1, put that here. And what happens sometimes if you forget to put the 1 and you just put the negative, then I've seen students just write 3x cubed and forget the minus 1 is even there. Okay, so my suggestion is even if you can only factor out a negative 1, put the 1 in just for yourself, just so you don't miss it. And then we look at these two binomials and say, okay, can I factor any of these any further? And sure indeedy, x squared minus 4, we can do difference of squares there, so we'll go ahead and factor that a little further. And now we're left with 3 binomials. So we started out with 4 terms in this polynomial being added and subtracted, and now we've ended up with 3 factors creating this product, and each factor is a binomial. So we've turned addition and subtraction into multiplication, which is one of the neat things about factoring. We'll make use of that in Unit 2. All right, so if I look at this next example, pretend I haven't already worked it, and you're thinking, okay, x squared minus 8x, we'll pair those two up, and we'll have x times x minus 8, looking good. And then I'll pair these two up, and I can factor out a positive 4, that's great. So I'm going to have 4 minus y squared. But then when I think about it, I factored out an x, and then I'd have x minus 8, and then I factored out a 4, and 4 minus y squared. And there's nothing further that I can do. So separating them into 2 binomials and common factoring hasn't achieved anything for us here in this expression. So this is where I'm introducing the thought that sometimes you have to factor 3 and 1, or if you have 5 terms in your polynomial, you might have to do 3 and 2, or 2 and 2 and 2. So there are different ways of factoring by grouping. It's not always separating the 2 binomials if you have 4 terms. In this case, we're going to factor the trinomial, see what we get, and see if it gets us any further along in the factoring algorithm that we looked at a few days ago. So x squared minus 8x plus 16, I know that factors to x minus 4 times x minus 4, and that little minus 4y squared, we're going to leave at the back here. When I look at this, I can see, well, I'm subtracting a perfect square. If only this first term was a perfect square, then I could actually do difference of squares. And what's neat is that this x minus 4 written twice, I can simplify to x minus 4 all squared. That makes this a difference of squares, because I do have a perfect square minus another perfect square, but sometimes it's sort of hard to work with binomial factors if you're used to working with monomials. So this is where you can introduce the notion of a dummy variable, where you create a variable that is nowhere in your expression. Okay, so I use the variable a, and I say for a little while, I'm going to let a represent my binomial x minus 4. I'm going to replace it in the expression where the x minus 4 was, and then I'm going to factor as far as I can until I can't factor any further, and then I'll just replace that x minus 4 back in instead of the a. So if we've got our a squared minus 4y squared, we end up factoring a plus 2y, a minus 2y. I can't factor these any further, so now I will replace that x minus 4. So now instead of a plus 2y, it's x minus 4 plus 2y. And instead of a minus 2y, it's x minus 4 minus 2y. We can simplify this. We'll put them in alphabetical order with the constant last. And now we've ended up with a pair of trinomials forming this product. Again, when we started out with 4 terms being added and subtracted together. So again, we've turned addition and subtraction into multiplication. If you can see this as binomial squared minus 4y squared, then you can skip the dummy variable step and go straight to binomial plus 2y times binomial minus 2y. Okay, so you don't have to use the dummy variable. I just put it in here as an option because sometimes it's hard to factor with binomials as a factor when you're just very used to using monomials. So let's look at example number 6. This is one of the ones I was telling you about a few days ago, where you've got your leading term has an even exponent, your next term has an exponent half that value, and your last term is a constant. So this one we're going to factor the same way that we factored quadratics. But this time, instead of just using the x as the first term in the binomials, we're going to use the x squared. So this new middle term takes the place of our linear term. So we're really looking at factoring a tricky trinomial here, where we know that the first times the first gives you the first. So we know that something times something gives you 4. It can either be 4 and 1 or 2 and 2. And that the two last numbers are going to multiply to 1, and we'll have a positive and a negative in there. So we'll just put our 1 and 1 and 1 and 1. So we can try out, do a little crisscross here to test what those two terms in the middle would be that we'd gather up to make that negative 3x squared. And here we've got 4 and 1, and I can use 4 and 1 to make negative 3 by making the 1 positive and the 4 negative. So that means I'm going to have 4x squared plus 1 times 1 x squared minus 1. And these two binomials that's the first step of factoring that we do. I'm looking at them to see if I can factor them any further, and this one I can't. If it was subtraction, I'd be able to, but this one we can do difference of squares, so we'll go ahead and do that. And we've turned a trinomial into 3 factors that have all been multiplied together. Last two examples, we can make a little bit more use of the dummy variable if you'd like. We can see that we've got a binomial squared minus a different binomial squared. So we can right away see that it's a difference of perfect squares. And what we'll do is we would take binomial plus binomial times binomial minus binomial. So we're square rooting both of these binomials. But again, if it looks like a little too crazy for you, I don't want to have to work with those binomials yet, then we can replace the first one with a and the second one with b. We've got a squared minus b squared, so then we'll just factor that using difference of squares, a plus b, a minus b. And when we can't go any further with these dummy variables, then we'll substitute back in what we started with, okay? And at that point, we're going to distribute the positive in here and open up those brackets, and distribute the negative in here and open up those brackets. And then we'll simplify the expressions, so we end up with 4x minus 4 times 2x plus 6, noticing that each of these binomials can be factored further. They can both be common factored. So I'll common factor the 4 out of the first binomial and common factor the 2 out of the second binomial. And then by convention, we'll multiply the constants and we'll put that out front, and then we'll have the two binomials that follow. Last example here, notice how we're doing a lot of difference of squares factoring, and that's because your future grade 12 teachers gave me feedback that this is the type of factoring you miss a lot. So you'll notice you're going to see it quite a bit in this unit, and especially on the mastery test. Again, we've got a binomial to the 4th power minus 16, okay? So again, if you don't want to use the dummy variable, you can go straight down to this line here. If you are more comfortable with the dummy variable, like most students are, then we can substitute the x minus 3 in for a, and now we have a to the 4th minus 16, which is difference of squares. So now we're going to have a squared plus 4a squared minus 4. This one will be a prime factor because we can't common factor it and we can't difference of squares factor it, so we'll keep that one. But this a squared minus 4, we can factor out to be a plus 2, a minus 2. And once we've gotten as far as we can go, this a squared plus 4, a plus 2, a minus 2, none of these binomials can be factored any further. So now we'll come back and we'll take that x minus 3 and we'll substitute it in. So now instead of a squared plus 4, we'll have x minus 3 squared plus 4, and then x minus 3 plus 2, and x minus 3 minus 2. Again, simplify and expand the brackets here, so we'll multiply this binomial by itself, getting x squared minus 6x plus 9 plus our 4. And this one simplifies to x minus 1, this one simplifies to x minus 5. So when we simplify it down even further, this first factor, we end up with x squared minus 6x plus 13, which can't be factored any further, times x minus 1 times x minus 5. So again, we started out with this binomial and this polynomial, and we've turned it into 3 factors all being multiplied together. So try out the homework factoring polynomials. We're one lesson away from your unit test. Make sure to bring any questions with you to class, and we'll see you next time.